So just to recap on yesterday's class, because a lot of people missed it. Now, I will just put the link up in future as well. But the link, you can get the link on your camera and using the movie icon at the top. Okay, when you're in your classroom. But I'll put the link in as well, so you won't be caught like that again. Okay, so no worries. Right. So what we were talking about yesterday was Newton's laws. Okay, Newton's laws. Right. Now you've heard of Newton because he was the guy who did Newton is named after force, so he's a big guy on force. Okay, the measurement, the unit of the Newton. Okay, so the first thing we looked at was what happens if you apply no force to something, and we decided after a while, after thinking about it, that nothing happens. Okay, you apply no force, nothing happens. Now, what does that mean? Okay, it means that if something is traveling at 5 meters per second, it'll stay traveling at 5 meters per second forever, unless you apply a force. Now, we talked through this yesterday and we said something's a bit dodgy, but then we remembered that in the real world, on Earth, there are always two forces acting, okay? And we wrote those down. They're the frictional force and the gravitational force. So friction, so we wrote down that, and I want you to write that down, that friction and gravity are these forces that usually happen. So when we're talking about the first law, and the first law is, and you're going to write this in, okay, if a body, we like the term a body in physics, okay, we're not talking about corpses, okay, it's not CSI, we're talking about anything that we can move, okay, so I would be a body, or this biro could be a body, and so on, okay, so a body moves at constant velocity, or speed, if there is no external force. Okay, so if you don't apply a force, it keeps quite the same speed. The reason we see things slowing down is that frictional force comes into play or gravitational force comes into play. So I kick a football from one length of a pitch to the other, I kick it, the force of gravity brings it down, and then when it hits the ground and rolls it on the ground, the force of friction slows it down. So that's why we don't really think in terms of that. The other obvious one is that if the constant velocity that we talk about is zero, in other words, it's stopped, well, it'll stay stopped unless we apply a force. Okay? So that's Newton's first law, done and dusted. Right? Third law we also looked at, we skipped to the third law, just to make it awkward. And we spoke about the fact that you all worry about swimming. Okay, because you learned how to swim, but when you learned how to swim, you found that to go in that direction, you had to apply a force in that direction. This was bizarre, okay? And you said, this is very dodgy. Okay, think about it. If I'm swimming that way, I push back that way. I push backwards to go forwards. And in fact, you do the same thing when you're walking. If you think about it, as you walk along, you apply force back into the ground, and the ground applies the force forward. Physics sorts the problem. Okay, so what happens is, sorry, looking here now again. What happens is that if I apply a force to a body, the body, like the water in the swimming pool, the body applies the same force back to me, but in the opposite direction. So if I hit this here like that, okay, I applied a force to the wall, I experienced a force from the wall. It was the same size, and the word we use is magnitude, so magnitude and size are the same thing. It was the same size as the force I applied to the wall, but it was opposite in direction, because I applied a force into the wall applied a force back to me. You can try it by running into a wall. Okay, if you run into a wall, you will apply a force to the wall will apply an equal force back to you. If you run faster into a wall, you'll be applying a greater force to the wall, and the wall will be applying a greater force back to you. Probably what we would call a thought experiment in physics, where you think about the experiment but you don't actually do it. So please don't run into a wall. Okay. Third law, the way we write it down is we talk about a body A and a body B. So if body A applies a force to body B applies an equal in magnitude, which is size, but opposite in direction, force on body A. Okay, so think of the swimming. Okay, I apply a force backwards to the water, the water applies the same force, equal in magnitude, but forwards in the opposite direction to me. All forces act in pairs like that. Okay, same when you're walking. Every time you walk now, you'll think, the third law, it's getting me from A to B. Without physics, lads, we'll be nowhere. Okay, we'll just be nowhere. Okay. Now, second law, we went through it yesterday. You don't need to think about the second law if you missed yesterday's class, because tomorrow is going to be about the second law. We're going to go through the second law again tomorrow, and we will do calculations, simple enough calculations on the second law. Okay, so that's what I wanted you to catch up on. Make sure you watch the videos, okay, because the kind of videos give you a little bit of clarity on the three laws, including the second law, but it'll be good to have it done before tomorrow, and then we'll talk tomorrow. Okay, great stuff. Talk then. Bye bye.